Hello and welcome to the second lecture on experimenting with software-defined radio. In this lecture, I will quickly introduce you to GNU Radio. GNU Radio is a graphical development environment especially targeted at developing radio systems. You can very easily put together a radio using graphical components. Now let's see how you start GNU Radio on your computer. On my Ubuntu system, I can click on the GNU Radio icon from the applications, or I can open up a terminal and launch the program by typing in GNU Radio Companion. So let's see how it opens up. GNU Radio programs are called Flowgraph. Your Flowgraphs are built from different blocks available in the program. The main work area in which you see two blocks, options and variable, is where you develop your Flowgraph. Your different blocks are shown on the right side. On the bottom side, you see a message window. There is another window in which you can examine various values. Now let us look at the Flowgraph. When GNU Radio starts up with a new Flowgraph, two blocks are automatically created for you. One is options block and the other one is a variable block. So let us examine them one by one. When GNU Radio starts up with a new Flowgraph, two blocks are automatically created for you. One is options block and the other one is a variable block. So let us examine them one by one. If you click on the options block, another window will pop up like this. The first thing you will see is an ID. So this specifies an identifier for your Flowgraph. Then there is a title. Then there is an author name, there is a copyright, and there are a lot of other, some of the things that are shown are quite obvious. And then there is an advanced option here, and there is a documentation option here. If you click on the documentation, you can read the documentation of this particular block. I changed the ID to my radio. I changed the various parameters to my own name and my own copyright description, etc. In the options block, there are a couple of very important parameters you should set. One is the output programming language. You can set this to either to Python or to C++. The Flowgraph, when compiled, will generate either C++ or Python. The second parameter that you should set up is the GUI parameter. GNU Radio can generate Qt GUI. Qt is a library, a cross-platform library with which you can develop graphical applications, graphical front ends. So there are four options. Say you can develop with the Qt GUI. So if you examine some of the Flowgraphs available on the internet, on some of them you may find a WX GUI. So that is another GUI library. So these days the newer versions of GNU library does not encourage using WX library. Your default installation nowadays may not have WX. So that is one thing you should notice. So let us move ahead again and look at the next block. The next block is a variable block. So by default, the ID has been set to samp rate. And there is a value also. We are developing digital radios, software defined radios which process data digitally. For digitally processing a signal, you should have a sampling rate. That sampling rate variable will be set as samp rate by default. You can change the name of the variable, but this is the convention. I am setting this to some other value, say 1 megahertz or 2 megahertz sampling rate. I apply and OK. Now your basic Flowgraph is ready. So you have defined parameters for options, which defines the GUI interface and other parameters like what programming language you are planning to do. and you have defined one variable. So this is a very simple flow graph. So let's move ahead and see what we can do with it. If your flow graph has some arrays, this particular red button will be active, and if you click on that red button, your arrays will be displayed. Unless you fix all the arrays, you will not be able to compile or generate the Python programs or C++ program from the flow graph. Since we don't have any arrays, you can click on the run button and click on generate. This will compile our flow graph into a Python program. This will ask you to save your program into a GRC file. The GNU Radio flow graphs are saved with the extension GRC. So I am saving this to myradio.grc. Now again I click on generate. So if you see the message window, the various messages are displayed. So this has generated our Python program. Now you can execute this particular program. And if you when you execute this program, if you find this kind of an error or this kind of a pop-up, don't worry. See, this is because system is finding it difficult to find out a program called xtep. So normally this will not be a problem. Your system will take whatever terminal it's available on the system. If you have an issue, if your program doesn't work beyond this point, what you should do is you can install a program called xtep using apt install xtep. So I'm skipping that step here. So assuming that xtep or some kind of a terminal is also installed. Now my radio program will start up. So this is the output from my radio program. You see there is nothing. We haven't specified any particular action for this radio in the flow graph. However, as the GUI has come up, you can build additional blocks into this flow graph. Build your controls and put your controls into this particular GUI. So since we have generated a Python program, let us go ahead and examine what that Python program looks like. Our flow graph was compiled into a Python program. For that, open up a terminal and look for this particular Python program which was generated by the GNU Radio Companion. GRC or GNU Radio Companion flow graph as my radio. Probably you might remember that in my options block, I had put the ID as my first radio. The name of your Python program so generated will be taken from that ID field. So my first radio .py will be the generated program. The myradio.grc is the flow graph file that I saved. So let us examine these two. You can open up the Python program using some kind of an editor. So this is the content that was automatically created. If you carefully examine that, you will find a class named my first radio. So various parameters have been defined here, various variables. If you carefully examine that, your variable was also defined inside the class. If you are familiar with Python, you can very easily tweak this Python code and you can port this to some other environment, some microcontroller, etc. The idea of GNU Radio Companion is to help development of such programs in a graphical way. What you do is you select a set of blocks and place it into the flow graph. You interconnect the flow graph and compile this to a Python program. This Python program, or maybe you can also compile that to a C++ program. This you can port to any platform provided you have the GNU Radio library. So let us examine in detail how you can actually use this. Let's add one variable to this flow graph. Examine how you can vary its value. So look for Qt range block on the blocks pane. And so you can search for Qt here, and if that search window doesn't come up, you can click on that search button here, that will automatically come up here, and you can type in Qt. So it will show different GUI widgets that you can use. So choose this Qt GUI source, bring it to the flow graph area. Okay. Let us examine this particular block. See here, you can set ID of the block. Variable ID has already been set by the system default. You can set the values here, minimum value, maximum value, what should be the range of that value. So I'm going to change this to frequency. So the label that is displayed will also be changed to frequency. So it's a floating type variable. There are two types of variables possible, integers and floats. There are other things you will find later. So default value I am going to do 100 megahertz. Starting value will be 88 megahertz and ending value will be say 108 megahertz. This is the FM frequency range. See, please note that for specifying megahertz we are using E6. This is the styles that's possible. How the GUI widget should look like, whether it's a counter slider or it's a knob. You can experiment on this. Once you've chosen that, you can press OK. Again, generate and execute. So this is your widget. You can vary the slider. You can vary the slider and the value will automatically change. Okay. So you can experiment the options for like knob. The next flow graph, we will build a very simple function generator. For that, we will use our Qt GUI range. So this will be varying the frequency of the function generated. So we will add a couple of more blocks into the flow graph. So let us do that. We are going to change the ID of the Qt GUI range to frequency. Let's do that. We have already done that. Let's change the default value to 10 kilohertz, 10 E3. Just then starting value will be 1 kilohertz, ending value will be 20 kilohertz. So you see how the numbers are typed in. So this is our, you can see, examine this particular block. Default value is 10k, starting is at 1k and ending is at 20k with step size of 1. Now again, choose a signal source from blocks window and bring it to the flow graph. Click on it and you will get this kind of a pop-up. So you're going to set this to float. So the generated signal will be simple floating point sine wave. So you can generate complex sine wave also. We'll come to that later. See, we'll keep the sampling rate as it is. So your sample rate has been set to 2 megahertz. Waveform type we will set to sine and frequency will be taken from the Qt GUI widget named frequency. This ID we have already set earlier. So that will be imported into this signal source. Then you need an oscilloscope kind of thing to display the signal. Search for Qt time sync, choose it, bring it to the flow graph area. And here it is behind my head here. Here it is. Click on that. So this will come up. We are generating floating point numbers. So we'll change this to float. The sampling rate is already set by default. Now you can join together these two by drawing a line here. You can click on this out and put it to the in. Function generator is ready. So it will generate, signal source will generate some signal and the Qt time sync will display it. You see the output that we have generated. So your signal is here. This is the Qt time sync block and this is the Qt GUI range block. As you change the signal on the frequency, see that time period changes. This is how you can make a simple flow graph. We will add one more thing. We will add a frequency sync. So we will display the FFT. So for that there's a Qt frequency sync which displays the frequency. So let's do that. You can click on that. So you can join the connections. You see from the signal source you are connecting to the frequency sync. Change the values, the type to float. Okay. Then you can examine where are the various parameters that is available. Now you can run it again. When you run it, you will get a display like this. Here there's a range widget with which you can change the values. The corresponding to that change, both frequency display as well as time display changes. So that completes this particular experiment. Now you have seen the time sync and frequency sync. Now let us bring in an audio sync and see whether you can listen to the signal from the signal source. So for that, so let us bring in a audio sink. Look for an audio sink, bring it to your Flowgraph area. You need to give a name for the device. You can just run the program. So you will see the thing. As you vary the frequency, the audio output also varies. Let's modify this flow graph further. We'll introduce a constant multiplier between signal source and audio sink so that its amplitude is boosted up. So you can multiply the signal source, so signals coming from signal source with some constant and amplify the signal. So let us examine that. So what I'm looking for is a multiplier constant. I will look for a multiplier constant block. So bring it here, connect it. So that multiplication factor you can either make it float or make it integer. So I'll make it float here, multiply with some value, connect it here, then connect to the audio sink. You can vary the values, then run it. Loop are varying the frequency from 1 kilohertz to 20 kilohertz. So let us bring in a low pass filter so that we don't want any of the signals above 5 kilohertz. Maybe you are running a telephone exchange or a telephony application. You need a very low bandwidth. You need to filter out. So GNU Radio offers filter blocks, low pass filter, high pass filter, all kind of filter blocks here. You can very easily bring in and experiment with filters, various filter parameters. So let us do that. So I will look for a low pass filter among the blocks. I will found out one and brought in here. You can click on the low pass filter widget and find out the parameters. See, you have several options what kind of filtering is to done. I have chosen float to float because our signal source is float and our audio sink is also float. I have taken float to float decimating low pass filter here. You have to choose the sampling rate, gain, and then you have two parameters. One is cutoff frequency, other one is a transition width. If you keep the transition width very low, you will have a very sharp cutoff. You can experiment the various filter options here. So I will show what I have done here. Let's see. Here I have set the transition width to 10,000 is very high, and the low pass filter also to some low value, say 3000. And then when I run it, so I'm removing that connection here. So send to the low pass filter, then back to audio sync. I have removed that GUI frequency sync for clarity. These two are remaining. So it's okay, connected. The connection diagram is ready. Now you can run it. Just see, yeah, compiling it. Now, as you change the frequency, you can see the time sync becomes better. Frequency, listen to this on an audio sync. So if you can experiment by changing the transition width, the cutoff frequency, and listen to the actual signal here. So run it again. You hear the difference. Now you can try the other way around. High pass filter also you can try. You can choose different kind of filters and very easily experiment. So remember that everything, these blocks are compiled into Python programs. which you can run on a different platform provided you have all these libraries. So in the next lecture, we will look at how to build an FM receiver using real hardware. So far we have used a signal source only and an audio sync. Now in the next lecture, I will demonstrate how the RTL SDR dongle can be integrated into the GNU radio and you listen to original radio stations.